Hi, everybody. My name is Dominic, and today I'm going to present our work on aligning ranking objectives with e-commerce search intent. This is joint work with Ehsan, Ebrahimzadeh, Alex Cozzi, and Abraham Bagherjeiran. We are part of the eBay Search Ranking and Monetization team. I want to start by discussing an observation we made when we look at users in an e-commerce setting and their shopping behavior. We find for this, we plot the user attention over different ranks on a search result page, and we divide the users by the user intent, which one is exploration or browse intent, and the other is focus search or purchase intent. We find that in the case of users that are exploring, they tend to pay more attention to lower ranks on the search result page, whereas users in focus search engage more with the top results, which we could see in a sharper decline in the rank decay of this function. The research question that we try to answer in our work is whether we can modify the ranking objective such that it aligns with users' varying intents. I want to start by introducing the problem setup. What we are interested in is calculating the expectation of a DCG-based loss function between the output of a ranker F, which basically gives a score to each document in a document list DS, with respect to the ideal ranking, which is introduced by this ranking function R, also on that same document list. And I wanted to point out here that the difference with existing works is that usually existing works try to enrich the query context by modifying that feature vector, which is passed to the ranking function. However, our method is feature agnostic, as we only change the ranking objective. So this equation can be rewritten as an expectation of a rank discounted vector of these functions, of these scores that are provided by our ranker F, and this ideal ranking distribution conditioned on the search context S, which we can think of as a query context. Using the tower rule, we can decompose this into an expectation of this score vector on the left-hand side, multiplied with a vector of probabilities, which runs over each document in the document list, where each entry in the vector is basically a probability of the binary search intent of that user, conditioned again on the search context. So what we focus on in our work is to adjust the label distribution based on the search context, and specifically whether the intention is to browse or to purchase an item. The main idea of our work is to stratify the training data based on the different intent groups, whether we are in exploration or focus search mode. However, the user intent distribution is not known beforehand. So what we do is we adjust our empirical labels to approximate the underlying item desirability distribution. So for browse intent, we use the empirical click engagement distribution. For focus intent, we use the empirical purchase distribution. And what this means, I want to explain an example here. So imagine we have this checkout for this user flow, where we go from the search result to the item page to the checkout page to a purchase. Then we can estimate the click distribution C given C of DS by looking at all the items that have been clicked on an SRP. Similarly, we can estimate our purchase distribution P using all the clicks that actually led to an eventual purchase. So you can imagine this set C is much larger than P, because P is basically a subset of C for all items that have received a purchase. So the way we stratify our data to match the intent-based desirability distribution is as follows. We basically calculate our loss function L as a sum over different intent-based strata with intent probability PI. And PI can be controlled using what we call the important sampling parameter alpha. which controls for the mixture of purchases P and click queries. I want to focus our attention towards the evaluation of our methodology. And I want to start by introducing the experiment setup. And the evaluation task that we choose is we do not evaluate on the easier task of estimating the click and purchase distributions, because the rankers are specifically optimized for these clicks and purchases. And we argue that this is more or less a straightforward task to evaluate. Instead, we pick the more challenging downstream performance differences on queries originating from two different sets, where one set is the search result pages and the other the browse pages. But this means I will explain in the next slide. And we argue that this basically measures a better generalization of the rankers on these different query sets. The data sets that we use for training is the proportion of queries with a purchase event in the search context, which again we can control by the important sampling parameter alpha. In the case for test queries, these are based on a random sample of queries for which there is at least one click observed in the search context. And we evaluate separately the performance on search result and browse queries. So next I will explain how we separate the queries into browse pages and search result pages. If we are on the eBay homepage and a user would click on one of the categories seen here, this will mean that he is in an exploration mode, and the query that he or she will encounter will be counted towards the browse result page set. In contrast, if a user issues a keyword query, we would say his intent or her intent is focused search, and that query of that user will add towards a set of SRP queries. Once we have the separation by user intent, we can basically identify different user engagement patterns for SRP and BRP pages. And in the plot on the right-hand side, we see the click propensities for search result pages divided by the click propensities for browse pages. And we plot this over different ranks in our result page. And similarly to what I discussed in the very beginning, is that users with exploration or browse intent engage more with higher ranks, as we can see this drop here in the SRP to BRP ratio. And users with a focus search intent, which have issued a keyword queries, focus more on the top slots of the SRP page. Moving on to our evaluation results, where we performed the empirical evaluation of our rankers on our test data sets. The way we do this is we train separate rankers on purchase queries only. This will correspond to an alpha setting of 1. We compare that ranker to a baseline ranker that is trained on the optimal mixture of purchase and click queries, which we call A star in this case. And we compare both rankers on the difference in terms of mean reciprocal rank of the first click event in the search result page, and the mean reciprocal rank of the first purchase event in the search result page. We find that if we add more diverse queries, which corresponds to an alpha smaller to 1, improves the performance on the browse result and search result test data sets, and it improves for clicks and purchases simultaneously. The effect, however, is more pronounced for browse result queries, which we can see in this column. Summarizing, we can say that adding queries with click engagements is more beneficial for browse result pages, and thus should be the preferred method of training the ranker. In summary, we talked about how we can stratify our training data to make it intent aware in our learning to rank task. And we propose to choose the strata based on the empirical target labels, which are estimated or which estimate the item desirability distributions in different search interaction scenarios. We identified different user engagement patterns where we find differences in the rank decay in click propensities and also engagement likelihoods for varying user intents. Then we evaluate the effectiveness of our methodology, and we measure this on e-commerce search logs, where we divide our tests into browse and search result pages to as a proxy for search intent. And then also we highlight the variance in the ranking efficiency for these different intent segments. Thank you so much for your attention. If you have any questions or concerns, please feel free to reach out to one of us using the email addresses shown on the slide. Thanks again.